Hey guys, let's talk about this word problem using a quadratic equation with irrational roots. It says a ball is thrown from a height of 182 feet with an initial downward velocity of 12 feet per second. The ball's height h in feet after t seconds is given by the following. And I'm actually going to rewrite this just because I want you to see it in this form also. H, that's the height, equals negative 16. This is the force of gravity pulling down on our ball. T squared, that's our time, minus 12 feet per second. That's the initial downward velocity where it gets thrown. So it's actually getting a downward push to start. And then plus 182. And that 182, remember, that's the C, that's our y-intercept on a graph. That's the height that the ball is going to start at. So there's a nice little picture here. The ball's up here. Someone throws the ball down. It not only gets this force pushing it down, it gets this gravity pushing it down. And we're going to see that negative 16 making a parabola that looks something like this. Okay, so over here, that didn't really happen. The ball actually really started here at 182 feet, and it, over time, time's going this way, went down to the ground, and so we know that when it hits the ground here, the height will be 0. So here, the height is 182, and then here, when it hits the ground, the height is going to be 0. So our question here is, how long after the ball is thrown does it hit the ground? So we're talking about this. When it hits the ground, h is going to be 0. So let's go ahead and plug that into our equation. We have 0 equals a negative 16t squared minus 12t plus 182. And we need to solve for t. So very often in real life problems, the numbers just aren't particularly nice. And we can, in fact, here's a hint. You're going to round to the nearest hundredth. That's a good indication that you're going to use a calculator, which Alex, when I'm looking at these sample problems, does not give me the calculator to show you. But we can plug this into the quadratic formula. So we have x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Are there other ways to solve quadratic equations? Yes, there are. I'm just jumping to this because I'm assuming that the numbers aren't particularly nice. I probably could factor something out here, and it might be fun to play with this, but this might be the fastest way to solve this. You're welcome to try factoring out a common something there. They're all even numbers, so you could factor out something and then maybe see if it's factorable beyond that. Probably not, since we're rounding to the nearest hundredth indicates that our x-intercept there is not going to be a nice number. So it's probably a good hint. We might be able to complete the square, something like that. Anyway, here's one technique. We're going to fill in the numbers like this. X equals, okay, this is b right here. A negative b will happen to be positive 12 plus or minus the square root of b squared, which is 12 times 12, minus 4 times a, here's a right here, times c, all over 2 times a, which was negative 16. All right, and so a calculator is going to be helpful here. You're going to do one of the answers as a plus and then do it all over again to get a minus. What's going to happen is you're going to end up with one negative answer, and that doesn't make any sense. Time is not negative. So we're going to throw that out. The reason that exists is because even though we threw the ball from 182 feet high, the sort of mirror image of the parabola over on this side, you can see I'm making it blue, it doesn't really exist, but the symmetry shows up on the graph. And so that negative answer comes from the x-intercept that would be right there. It didn't happen. We actually climbed up a ladder or a staircase or something to throw that ball off from up high. So we're going to throw that negative answer out. And whatever the positive answer is going to be the root or the solution or the x-intercept or the zero that we're actually looking for. It's going to tell us the time in seconds that it's going to take it to get to the ground. It doesn't usually take things very long to fall like that, so expect that number might be kind of small. Let's go ahead and just pop over to the explanation and you can see that happen here. All right, they use the quadratic formula in their demo also. And notice that we got negative 3.7684 irrational number and positive 3.0184 irrational number. And so we're going to throw out that negative 3.7 and keep the 3.0. They wanted us to round it hundredths, so we're going to keep 3.02 seconds. We can ask, is that reasonable? Yes, it's reasonable because it's going to take about 3 seconds for that ball to fall and hit the ground, especially when we've given it a pretty good push and gravity is pulling it down really hard. So hopefully that helps. If you're not getting the right numbers, a good thing to check is how you're entering things in your calculator. When in doubt, use parentheses to isolate things. And if you continually get a wrong number there, just bring it to me and I'll go over that with you, because it just might be entering into the calculator in a way that the calculator's not giving you the right answer. So hope that helps.